All right, welcome back to one more video about ECS. So in this CS, we're going to tackle something that pretty much a lot of people have tackling when you start researching this. It's hierarchy. How do you handle the transform hierarchy? And usually a pretty good consensus is just build another component, essentially, and just build it that way. So you can just make it dynamic if you need it. So that's where the approach we're going to go. So let's look at the original transform that we have. Transform, we have something called model matrix. Before ECS, I used to have a local matrix and a world matrix. I'm doing less emphasis on matrix stuff in this version, so I'm just calling it model matrix. So on one of the previous videos, I said this is not necessarily local matrix. It can be both world matrix too, depending if I'm going to use a hierarchy or not. So model matrix ends up being the exact model matrix that we're going to upload. So that will actually change depending on if we're using hierarchy or not. So it could be local or it could be world. So to me, for the most part, this is really just a cache, just caching the data. So this way, we're not constantly recreating it if it hasn't been modified. So this is what the transform looks like. Now our hierarchy component looks like this. We're going to have a level. We're going to keep track of what parent it is. We're going to track if the parent has been modified, and we keep track of children. So every hierarchy knows what a parent is and knows its children is. So we keep track of both. And level is very important. It's because I need to build out everything as a flat. So in the previous iteration, we would create a component and kind of just add it. And the only way to know it if the children was on the list was to actually flatten out the hierarchy. So everything was a hierarchy in an object-oriented way. In this system, everything is flat and everything just has references back and forth to each other. That's all it is. So when I add parent and child, when I'm dealing with parents and child, I start updating the level value. So if you're the root element, you have a 0. If you're a child of that parent, you have a 1. If you're a child of a child, you have a 2. So we keep track of levels. And why am I tracking of levels? Because I need to process the model matrix in the right order. So since everything is a hierarchy, I need to process all the parents before I handle all the children. So when I do a search for entities, I say, okay, give me a list of entities that have the hierarchy or that has a transform and the hierarchy or whatever. It has to transform. But at the same time, sort it by level. So that means all parents go first and all children go second. So this way, when I process everything and I see if there's a parent, I can say I grab the parent's model matrix and multiply by my child model matrix, which then creates basically the world matrix. So it's me just really playing with the data and making the data as minimal as possible. Like I said, I don't have world matrix and local matrix. I don't have any of all this stuff. Everything's kind of like building blocks kind of set up. So the data for hierarchy becomes super minimal. There's only 4 bits of information. And like I said, this is very functional programming, so we have functions. We have a function that handles how to add a child. So you have an entity parent and entity child, and this is just how to apply a child, how to set up that parent-child relationship. It's somewhat similar to what we did in the past. I don't need to illustrate. I don't want to waste too much time explaining because it's really just JavaScript code, and there's a lot of comments on the screen that you can kind of read really quick and get an idea. But it's just setting up a reference to the parent and then adding the child and then basically updating its level based on the parent's level. So if the parent has a level of 2, the child's going to have a level of 3. Very simple. And the only difference is I call it if you're changing something, like I need to update the child's level. So if let's say if this child is added to a parent, but this child also has its own children, this child gets its level changed. That means I need to update all the children with the new level. So I have to make sure that the level value is in sync. Everything is correct. So this way I can render everything in the right order. Because when it comes to hierarchy, transform hierarchy, everything needs to be rendered in the right order. Parents first, then children. And then you have the remove function. You pass in the parent and child entity, and it just takes care of it. It takes care of things itself. And this is the function that does the update. Very simple. It just adds one, and then it calls the update child again, just in case this element has a child. So this is a recursive function. I didn't build this as a stack because I don't do very heavy hierarchies. I try to make things very minimal because it makes things a little faster and easier to manage all that data if it's not like these long chains of hierarchy. I think the only thing that's going to have a long chains of hierarchy is armature bones, but that I'm going to have like its own object built in, so it manages itself internally. But that's something else. Now, when you're dealing with hierarchy, we always need to know the world position and the world rotation. Sometimes we need to know that. So how do we handle that? So what I did before is that I would just process all the matrices and then pull out the information from the world matrix. That's how I did in fungi. In this version, I'm not going to do that. I'm going to, let's say if I pass in the entity and let's say I want the world rotation of that entity, I'm going to scroll up the parent tree, find a root, and basically save an array of the traversal up the parent tree. And then I'm going to traverse right back down and multiply all the quaternion rotations. It's the same idea of actually doing all the matrix transforms, like you're going from parent to child to child to child, and this creates your world. I can do the exact same thing with quaternions. Quaternions works the same way as matrices, as long as I multiply them in the right order. So I have to multiply parent, child, 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 from level to level, and that gives me the world rotation. So that's what all this function does. It just goes up the tree, gets the list, and then goes back down that list and creates that value. Yeah, and that's like I said, it's right here. It's just quaternion multiply out stack, and that stack has that list of parents. And so yeah, I saved the first one. I just copy the first one, then from the second to last one, like this is the root. This is the root element, and then from the first child on, I just keep multiplying, and then I just give you the final quaternion, and that is your world rotation. So world rotation is just multiplying quaternions. I didn't build world position yet, but you do the exact same code, but the only difference is this part changes where instead you multiply all the positions, you just add up all the positions, and you should do it in the right order from parent to child, because negatives can cause problems when you're dealing with things. So make sure everything's done in the right order, and you're just adding them all together. And world scale works the exact same way as world rotation. You just go and you multiply everything from top to bottom, and that's how you can handle. And this is how I'm handling hierarchy. In ECM, and how to get the world rotation and world positions without doing all that matrix math. Just use the pieces that you need, especially and most often you need to know mostly is your world position, and world position is just a bunch of addition. So it's better to do a bunch of addition on just Vec3 as opposed to all this world matrix mathematics, which I was doing in the previous system. So this actually makes things super more efficient. And like I said, it's not very often I need to find out world position. But if it's something that becomes, like if you need to find out world position, world rotation very often, you can kind of just update, you can kind of fix maybe this hierarchy object to kind of cache those values. So this way you can, the last time this was changed, when did it happen, whatever. So you can kind of build more of a caching mechanism in it. But like I said, it doesn't need to happen that often. And when it does, the data did change. So whatever. So there we go. So that's the hierarchy. And the system, this system, now this is now special. This transform hierarchy system is going to replace the transfer system. So instead of having the transform system and the transform hierarchy, I'm actually going to I'm going to say delete the transform system and replace it with this system. This will actually handle both. So I didn't want to create two systems running that does the same kind of code. Because the model matrix is either world or local. It's either or. So I need this system to to render things the right way. So we have a sort function, and this function gives you the JavaScript the sort logic to sort things based on the hierarchy and the levels and everything else. I don't need to explain it. Very simple JavaScript comments. Here I did a pretty good job of commenting it. And like I said, this replaces our transform. So it checks to see if it's been modified. It checks to see if the parent has been modified at all. If it's modified, I create. So it's very similar to our transform system. Like I said, I end up copying, pasting this into here, and then tweaking it. It also handles our camera. Like I said, it replaces the transform system. So this part and this part is what was there. So this is kind of the new piece of the system. This is what when I'm dealing with hierarchy. So if H exists, if there is a hierarchy component, then we'll just start dealing with some of the logic. If there's a parent, multiply the parent matrix with our current model matrix, which is currently local because I just created it. And if this item has been updated, mark all my children as parent modified. So this way, since this is sorted by parent-child, then when I start rendering the next level, that hierarchy has been set that said, hey, the parent just modified during this system update. So this way we can check to see if parent has been modified. So if the entity itself has been modified or its parent has been modified, we're going to start running all this code. And that's it. And this is what handles all the hierarchy, processing the data of hierarchies. And this is that. And the last piece of the puzzle is the use function. Like I did in the previous, when I said I was using this use function, so this we can just add in functionality. Just like with our behaviors and VAO, I'm going to use hierarchy quite a lot. Not that often, but when I need it, I want to use it. So it follows the same process, but it's a little bit more evolved. So I load in the hierarchy and I run the system. It's like the same thing, but it also creates a new assemblages. So I can say create hdraw, which creates me a hierarchy entity that has the transform, the drawable, and the hierarchy components already built in. And then as you see here, I'm actually going to remove the transform system because this system kind of replaces it. So I end up loading it in, adding it, and then I actually take this one because it ends up replacing it. And it has the same priority value. So it becomes a complete replacement, and you won't even notice the difference. And that's one of the beauties of ECS is because everything is Lego blocks. So basically, transform is my black rectangle cube, and this new system is my red rectangle cube. It's the same block, different color, but when you plug it in, it kind of just fits in where it needs to go. So it's kind of like building Legos with your code. And on top of that, it updates the API function. Now, this is something that you probably wouldn't want to do, but I just thought, why not just go full force and just, since JavaScript is completely dynamic and it doesn't hurt, if I'm building this, I know I have this. So this way, I automatically create a shortcut, and it exists in my API class. So this way I can access it dynamically. So if I go into test, I have behaviors, I have that, I have my transform hierarchy, I'm loading everything in, and you're good to go. And I'm then calling API saying I want to use my new hdraw function that I just loaded in. So everything becomes very, very dynamic. And here we go. We have, and like I said, I'm using my dynamic VAO from the previous videos because I'm dynamically making cubes. Let's see. There you go. So I have two cubes. Now let's say I want to rotate A. The first cube, the A cube is the black cube, and the B cube is the blue cube. So I'm going to rotate A. As you can see, the black cube rotated, but the blue cube did not, because they currently don't have a parent-child relationship. So if I go down here and say, because I'm also loading in the hierarchy, and remember the hierarchy component also has all the functions. Down here, I just say, this is the parent, this is the child, create a relationship between the two. So click save, and then when I do a refresh, now the child world matrix updates accordingly to what the parent does. So the parent rotated by 45 degrees, so did the child automatically. And if I want to, I can compound it too. So I can just add another 45 degrees to it, to my smaller cube. So my 45 degrees plus the parent's 45 degrees means my cube is now rotated by 90 degrees. And you can't tell, but let's say if I do 20 degrees. See, now it's not perfectly 45 degrees. It just compounded it. It just changed it a little bit. So the transform of the hierarchy is actually rendering just right, rendering perfectly. And just to finish it off, add behaviors. So I'm adding a behavior, and I'm saying the update uses the spin animation function that I have on this page, and these are just some properties I want to add, and here's a spin function, and it just does that. It's kind of hacky the way I did it, but whatever. Like I said, it's JavaScript. You can do whatever you want. So this has a spin function. And the spin function also dynamically adds a raw line to show me where the forward direction is the cube. So this way I know that that cube is rotating. So the parent cube is rotating, and it rotates the child and the parent are both pointing in the exact same direction. Now, if I want to, I can then add a behavior to the smaller cube, and it has different values. It's going to have a different color. It's going to rotate at a different direction, at a different speed. And when I click refresh, now the two cubes are rotating in different directions, and now you can see what the forward direction is for the blue cube as opposed to the main cube. And this is there you go. ECS with transform hierarchy, all built in and very simple. Very, very simple. This is probably the end of the ECS, really, because now that we have, the ECS is now completely been, the entire framework that we need, the bare bones framework that we need for ECS has been completely built into Fungi. From here, I can do anything else I want. I'm going to move on to, maybe in the next video, I might do motion, start building very basic motion physics. This is kind of one of the reasons why I built the ECS framework, because I want to start dealing with physics. I want to do some automatic, I want systems that automatically move objects based on velocity. And then have a system built on collisions. So this way, velocity, then the collision does something else, and things like that. So I can start doing some really fun stuff, and by prototyping and just adding it to this, like adding a system, the components, and everything becomes automatically just starts working. So ECS makes this super easy to prototype, and we're going to start making things a lot more. Like I said, the first year was all about building the framework. The second year is really trying to do things, and even though I'm still doing framework changes, but it's for the better, so we can do more animations and we can do more things easier and better and faster. And iterate faster, because that's the whole thing about prototype. We need to iterate, and the ECS system overall makes things easier to iterate. Like I said, I easily just removed the transform system and added the transform hierarchy system, and then it takes care of all my regular transforms and my camera handling, plus handles this as well. So I could have always made it two separate systems, but I could just make it one system. It becomes down to how do you want to do this, and that the basic ECS file, that the basic overall framework makes it very, very flexible, very, very fluid, and how you want to do things. So that the whole ECS file that I ended up creating, like after the first two videos, I haven't changed it since then. This is basically the bare bones. This is everything I need to do ECS, just fine. So if you have your own framework, if you like using 3JS or whatever, you can probably take this and kind of integrate it into your own 3JS engine that you're building, or your game. So this I built it in the idea that this should run independently from Fungi. So hopefully this is something you guys can use, and it really gives you a really good example of how to build an ECS system. Again, it's not the most perfect, and I wouldn't say it's the best way of going about it. It's the best way for me. Each person has a different interpretation on how they want to build a system. Some people might know some really cool things about JavaScript that make certain things easier. Like I did some really funky stuff, especially how components, how do I do register. Some people that don't know JavaScript as well might be like, wow, this is kind of different kind of different. This is different, and it works in a very interesting way. Other people might have different ways of maybe doing assembling or how to do entity. So it becomes very flexible, and ideally this makes it easier to really just change in the future. So yeah, I'm really excited. I don't know about you. If I talk really fast, I haven't even had coffee yet. So if I talk fast, that means I'm really excited. I'm really happy, and I'm really enjoying myself. And I'm not saying a lot of ums either, which is great. I'm talking very fluid, and there goes the So let me end it at that. I'm actually all done with all my video recordings. This, like I said, I'm done. This ends ECS for the most part, and from now on, everything I'm going to be building is going to be built on top of Fungi and this ECS framework that I just developed. And I just showed you, I taught you how to build it. And again, if there's any changes or any improvements you see that I can do, definitely tell me. I'm all about improving this. And I can always do another follow-up video saying, hey, we can do entities better this way. Because of blank told me so. And I tried it and I liked it, and this is now officially part of Fungi. And that's it. Please like and subscribe. And again, I want to say thank you to all my Patreons. You guys help me out because I'm unemployed, so every dollar counts. And I know I keep saying that every other video, but it's true. Yeah. So see you guys in the next video, and hopefully we start doing some real fun stuff with physics and collisions. And I want to do things with voxels again, so I got to build voxels as a component and as a system, things like that. And actually, the best part is voxels uses dynamic VAO anyway, so most of that's already done. So I might just have to build an extra component that builds off of dynamic VAO. Yes. So yeah, see you guys at the next video, and have fun.